In the previous session, we were looking at the machine learning, and in machine learning, we were specifically looking at what is called as the linear regression. So the complete concept of machine learning is divided into several subcategories based on the problem that we are looking at. If you try to recall, if our y column, that is the label, is a continuous variable, then the problem belongs to what is called as a regression. And whenever the categorical value, right, the y value is a categorical, right, discrete. Okay, so that discrete means it falls under a category called as a classification. All right. Yes, go. I'm fine. Very fine. Thank you. Okay. So the linear regression was a concept which falls under the regression category. The y variable or the label is a continuous variable, and we are supposed to guess what value it's going to take depending upon certain columns in our data set, that is the x. So let's try to quickly go through the concept once, because we will be using certain concepts that have been used over here in our upcoming sessions as well. All right. So the linear regression tries to fit a linear curve for our data set. If the data set is two-dimensional, x1, x2, those two will decide on the y, right? It may be a higher dimensional case. It may not be a straight line. It may be a different maybe in case of a 3-dimension, it can be a plane as well, right? So we looked at the mathematics behind that, whatever you can see on the screen, and then we looked at. Okay, so then we looked at the concept that what is a loss function? Why do you need a loss function? And we could look at the various types of the loss functions as well. All right. Then we define what do you mean by optimization problem, because we want to keep the error or the loss as much minimum as possible. So when that minimizes, whatever parameters you have obtained for our problem, the theta values are the optimum parameters that are right that are fitted for our problem. Okay. Then we define what is a normal equation. Using a normal equation, the theta star can be calculated directly. Okay, so that's what we have seen, and then the mathematics behind the normal equation, etc. we have seen, right? Then we looked at the which particular library we might be using so that we'll be able to do the implementation. Then very important part, the splitting up of our data set. Okay, we need to split 80-20%, most common one. 80% is a development set, other part is a testing set. Test set goes aside. Development set can be used for validation, cross validation, k-fold cross validation, etc. Okay. Then what is a minimization problem? What we are trying to minimize, we saw. What are the various options of giving the data set? We saw. Okay, gradient descent, batch, mini batch, etc. we have seen. All right. Then for a regression problem, that's a linear regression problem, R square is a measure of the goodness of a fit, right? So far we have seen this, and we will be moving ahead to the classification sort of problems. All right. So under the same category of supervised learning, we go for a classification. So if you remember, the complete machine learning can be divided into basically two categories. First one is the supervised learning, and second part being unsupervised. All right, the supervised learning is actually having two different aspects. Now we'll touch only the supervised. I will not write under unsupervised. Okay. Under the supervised, we have the first category is regression. So where the y variable is going to be a continuous one. We have solved one such cases. Then regression, and the second one is a classification. All right. So we will be looking at the supervised classification. That's what our course content says we are starting with. All right. Now, again, under this, we have varieties of algorithms coming into picture. But we'll start with a very simple one and very easy to understand, right? And we'll be trying to derive this particular concept, our first classification algorithm, directly from a regression concept. Because regression is very easy for us because we have understood what exactly is happening on the regression side, how the machine is able to calculate the continuous values, right? Because we have seen the mathematics that actually becomes pretty easy for us, right? For the analysis purpose and understanding purpose as well as the implementation. Okay, so if you have seen the implementation part, that also pretty much straightforward. Whatever we had discussed in the theory part of the linear regression, we try to code it right from scratch. We took a data, we tried to pre-process the data by doing some data manipulation, right, using pandas, numpy. Then the next part will be directly using that normal equation, implementing the normal equation in a very straightforward fashion so that you can get the predicted values. And the rest of the things are also pretty straightforward. Even if we don't know how to implement by using the from the scratch, definitely you can start from start using the scikit-learn or any other standard libraries for the same purpose. Correct. So both versions we have seen, right? So our discussion will go in the same fashion for almost every algorithm that we are going to. First, we'll look at the basics, the maths behind that, the implementation part, how what exactly is happening on the background. We'll try to see if possible. If it is required, definitely we'll do the maths. We'll solve problems also, but most of the cases that will not be a case. Few cases we'll definitely do the maths also. We'll solve something. Okay, and after that, next we'll look at the basics of programming, right? And then we'll take one problem, we'll try to solve that problem by using the code. So this is our approach for every algorithm that we are going to study under the machine learning as well as the deep learning and the upcoming sessions. All right, to start with, so under the supervised classification, the one particular algorithm which is actually pretty much straightforward, but still it is pretty much uh, capable, pretty strong, okay, in classification, specifically the binary classification, but still this can be further extended to the multi-class classification as well. All right. So the one that is called as the first algorithm, it's called as a logistic. It's a logistic regression. So one common question I get always as soon as I write this, sir, it says regression, but how can you do this under a classification? Are you going to do a classification actually? So the answer is yes. We, though this name says regression, there is a regression happening on the background, but what we'll be trying to implement is a binary classification such as yes or no type. So that's the most simple problem one can get. So what could be this? What could be such a scenario? It's actually right. It's a classification. Specifically, we are looking at the categorical data, right? Inside the categorical data, we are specifically looking at, say, binary. Binary classification. What do you mean by binary classification? There will be only two classes. Okay, so something could be something like is it class A or class B, right? Maybe you can call it as a positive or negative, 0 or 1, something very similar. Okay, very simple. Now, what could be your inputs? Inputs could be most commonly a tabular data. Tabular data we are already familiar with. One of our previous example was on a tabular data itself. Okay, we had several x1, x2, x3, maybe x6, so many things. Depending upon that, you decided y. So this is x, this is y. Y could be, now this has to be a categorical data. 0 or 1 should be there, or yes or no should be there. Okay, cat, dog, class, like that. Okay, so this is what we require as of now. But now the representation, let's try to look at the mathematical notation we had used earlier. Okay, we'll be using the that same notation once again over here. So for that reason, let me try to write it in this way. So if you remember, there is a x which acts like an input. There is a machine learning algorithm. Previously we had written the same thing. Okay, just try to recall, that's all. It actually predicts a y, right? We know what is y. Maybe it is going to predict a y cap, right? How do you decide the y cap? Y cap is equal to h theta of the x and the theta. Theta is the parameter that the machine learns how to relate the x with the y. If you remember, the ML concept is such a way that no rule based learning. You don't tell the rule. You tell this is the input, this is the output. Machine has to identify what is the rule. So rule will be defined by using the parameters denoted by theta. Okay. H can be understood as a hypothesis which it creates in terms of the theta to relate your x into the y. All right. So now what is the condition? How this theta is going to be how the theta will be decided? If you remember, it has to minimize, right? Minimize that error. Maybe I can call it as another function g of y cap minus y, right? Y cap minus y gives an error, right? You can convert that into a loss by taking a magnitude, squaring, etc. Many things we have learned, correct? So this is the minimization problem, optimization problem. So not only calculating the values of theta, but in addition to the calculation of theta, you are supposed to perform what is called as an optimization. All right, very straightforward. Let's keep it as simple as possible. Now, I'll ask another question. I'll ask a question before going to this the concept of our logistic regression. All right, before we start that, now this question is optimization. Optimization means out of many possible values of theta, you will select the most appropriate one. Correct? I hope that sentence is very clear. Everybody understands that. Now, let me try to give a question to you so that you can try to answer. Okay, so let's say this is the x versus, all right, let's say this is x1, x2 maybe, and I have a few classes. Okay, this is class 1 data, let's say. All right, and this is a class 2 data, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are the two classes. It's clearly visible that it is separable by a straight line. So let us try to fit a line which actually separates them. So let me try to say that this is a straight line that separates them. Okay, some classifier, let's not worry about what classifier, which one generates this straight line. We'll be trying to answer that at a later stage. Okay, so as of now, don't worry, there is a classifier which knows how to draw a line separating the classes. So already we know that Okay, if it is a linear classifier, this means we are supposed to design the theta values, correct? So theta star, right, should be optimum. Theta star can be multiple values also, because if you are writing x1, x2, etc. So normally, how do you write? The values of y could be x1 theta 1, x2 theta 2 plus some theta naught coming in the picture, wherein theta 1, theta 2, theta naught are the theta star, what we are calling here. Okay, I hope you are able to recall this. Now, you see, I'll go back to the graph, right? Why I said theta star has to be optimum, because look at this. I will draw another straight line. See, this is also a classifier. That's also classifies the same. Okay, the two classes. I can draw another class, another straight line, maybe like this. This is also going to classify it. Now my question is that which out of these, maybe because the red colored line will have theta star will be like 1 comma 4 comma 8. 1 is x1, 4 is x2, 8 is not sorry, theta 1 theta 1, second theta 2 is 4, theta naught is equal to say 8. Maybe that's one. For another one, green color line, it may be different, 20 and 30 and 8. And the third line may be -4, -10 and -100 maybe. So you see, we are supposed to find out three different values, and for theta, that is theta 1, theta 2, theta naught. There are many answers. Actually, if you look at this particular problem, this problem has infinite solution. Do you agree? Because infinite lines can be drawn separating these two classes, which means out of those infinite, right, what you call infinite number of lines possible, I have to pick one. Okay, that is what we call optimum. Optimum theta 1, optimum theta 2, optimum theta naught 1. So my question is that how do you decide on what will be your idea if I ask you to choose one? What do you do? Okay, take your time, think about that, and come back with the answer. We are open for discussion. Okay, I hope the question is clear. Anybody? Yes, the question is that out of many straight lines possible, each straight line comes into picture because of one set of theta stars. Theta star will have, in our example, three values: theta 1, theta 2, theta naught. Theta naught is a constant. You can consider it to be the y-intercept. Correct? So out of so many straight lines, in this case, as you see, infinite straight lines are possible. Correct? Now my question is that because we already have optimized that, in such cases we have never seen a problem. But there are possibilities like this, what you see on the screen. In these scenarios, what should be our approach in deciding the optimum values of theta? Okay, we have one answer, but the answer is in the form of a question. So let's see. So we can take the mean of the two clusters, something like the centroids of two clusters, and find one straight line which is perpendicular to line joining them. Okay, but how can you? It's an answer. Answer is right. This is a possible solution, but how can you say that that is optimum? Is my question. There has to be some parameter saying that okay, these theta values satisfy whatever condition you state, and so I select that as my answer, because optimized in the sense, in some sense, this has to be something like, maybe you can say that I save the memory in this case, or easy to calculate. Sorry, easy to calculate, or in some way you need to justify that okay, this is why I'm calling my answer as a optimum. Okay, that theta which gives the minimum error. Okay, fine. So closest answer as far as our discussion is, our past discussion is considered, this is the closest answer, I think. Anybody else, any other versions of your answer, please put me. So Ruchi says the theta which gives you the minimum error. So if you remember, we had calculated a y column, okay, y cap, which is a prediction of the machine. We compare that y cap with the actual answer y, because I know that what is the answer, that is y. So y minus y cap was error. Error could be positive or negative. We converted the error into positive by taking a magnitude or squaring it, if you remember. Okay, that's fine. Now if the error has to be minimum, let me give an example, right? Why this minimizing error could be one of the possible answers I'm trying to justify. Okay, so that could be, let's try to calculate the error part. Okay, so we know that okay, this is how we define the error. Error is equal to, depends upon what you calculate. Anyway, I'll put a summation of the y minus y cap the whole square, right? So this is how you calculate the error. Now the error has to be minimum, because what is your y cap? Y cap is nothing but, can you answer? X into theta, right? Theta is theta 1, theta 2, theta 3, or theta 1, theta 2, theta naught. X will be x1, x2, and 1. So it's actually, I'm multiplying. So mostly you will write x transpose theta according to the requirement of matrix multiplication. Fine. So you see this theta has to be, right, what? So because you see this is minimum. This is what should be minimum. This is minimum under what condition? Right? The sum should be minimum. I have to write the y cap minus y, or y minus y cap the whole square. So I have to get the theta under some condition. What should be the condition so that, right, you can get this condition satisfied? Can I minimize? Can I say that? Because you see here, could be one reason. X, I don't have any control, because X is any possible input that might come, right, belonging to each of the class. So now, though I have used only these two classes, see the X may be coming here, right? X may be coming here, right? That can have a different values of X. Like one could be 1 comma 1 comma 10. Second one could be 1 comma 100. That's still on the same side. Okay, so I don't have a control on X. Same thing with the, right, these x1 x2 we cannot have. Right now, see the point is this. Let us say I have, let's assume some values for theta now. So I have, say this is first set of theta, I call it as theta 1. So we have three values, theta 1, theta 2, and theta 0. One could be 100, 200, and 25, let's say. Another one could be another set. Okay, this is theta 1. Similarly, I write theta 2. Oh, notation wise, there may be a confusion. This is the second set of weights, second set of sorry, parameters. So I got as theta 2. If I write on the top, it's a second set. So maybe I get like 1.5, 2.5, and 1.75. Let's say assume. Okay, it may not be a right answer for our case. Now my question is, which one you select and why? So second set you choose, or the first set you are going to choose? You have to answer that, and you have to you have to tell why. Or maybe I can give you another third set with the negative values also. Fine, but maybe this is going to make things very clear for us. Out of these two sets, which one will give you the which one can be the optimum? Yeah, second one. Okay, why? What could be the reason? Values are smaller, correct? So smaller, whenever you multiply, correct, right? Values are smaller. So there are two aspects: smaller values into, right, instead of multiplying 100, 225 into some x value, multiplying with 1.5, 2.5, 1.75 gives you a smaller answer. That's one. Okay. So whenever answers are smaller, it will indicate that your answers are closer to y. You can think that error is minimized. That's the first one. The second thing, it's not true always, but still most of the time. And the second one could be, these numbers are easy to store. Smaller numbers means lesser memory required in my computer. When I have a huge number of theta values to be computed, right now we are not seeing that scenario in any of our problems. Okay. So for example, previously we considered 6 columns, only 6 values of thetas were there. Okay, theta 1, theta 2, etc. But this problem is a very dominant problem when you go to the deep learning, neural networks. Okay, towards the end of the machine learning, we'll touch the neural network. Okay, and there you see that these parameters are nothing but the weights of a neural network. There will be 100 neurons in one layer, such 10 layers. So 100 into 10, 1000 parameters, 1000 weights needs to be updated. So these theta 1, theta 2, theta dot 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 up to theta 1000 needs to be changed every time you learn. So that's a concept that's going to come up. At that point, if your theta values are 100, 1000, 10,000, 20,000, those numbers, that storing takes more and operating those numbers takes more time compared to the smaller real numbers like 1.5, minus 2.5, etc. Okay, so again, we are not touching that as of now. Let's keep it as simple as possible. And the answer is yes, if you keep these numbers smaller, right, they are easy to handle even for the computer. Okay, so two reasons I just looked at. Okay, so now I have another question coming up. This is more important to answer. Now I'm saying that, okay, I'm asking the computer, how do I say the computer that out of all the thetas that are possible for you, like depending upon the number of straight lines, right? I'll draw again just to say that this is straight line number 1. Okay, this is straight line number 2, and there could be another straight line, say straight line number 3. Let's restrict our discussion only for the sorry, I change the color. Let's restrict the discussion only to 3 straight lines now, but later on anyway it is easy for us to extend this analysis to go beyond. Okay, so let's say there are 3 straight lines like this. So this one has a theta star. I'll write theta 1 star, indicating optimum for this, or star is not required. Let me remove that because that's not optimum, right? That's a theta 1. So this has another set of theta 2, and definitely this is the third one, theta 3. Okay, now out of these 3, any one of them is minimum. One of them is minimum. Now, when you do the programming, you may have a facility to say that minimum of something possible, but that's not a what you call using a if condition, or any conditional statement is not suggested in any of the programming language unless and until it is absolutely necessary. Okay, now also I still do the same thing. I first think, can I do this part of the code without using a if or any other condition? I'll check that. So if unless and until there is no other way, none of the other techniques work, then only we have to go for the conditional statement. So if else will come only under such condition. So now I'm asking a question in that. Eliminate the concept of asking the if or minimize something like that. I don't want to use. You cannot use that. Without using that, can you do something to tell machine that keep your thetas minimum? Because what I'm trying to calculate, you know the equation. I have a parameter called loss that is equal to summation, depending upon number of rows you have. Maybe I is equal to 1 to n. You will perform the same thing, correct? This is yi minus yi cap, maybe the whole square, or you take the magnitude if you want. Doesn't matter. Okay, so let's stick to the squared. Okay, squared sum of the squared errors. That this is what we are calculating as a loss function. You know why it is loss, right? I think I have defined that, because if when I train the machine does not learn, means it is a loss. It's a cost for me. right? I have to train it again. So that's actually a cost. It's even the cost function, you can call it as a cost function or a loss, error, anything is fine. Now, how can you bring the concept that the theta has to be minimum with this equation is my question. In this equation, what else you can do so that you can perform an optimization? Okay, optimization also needs to be taken care along with this is my point. How can you do some modifications in this code, in this equation, so that the minimization of theta also will be taken care automatically? So what is your idea? Your idea is to minimize this loss, correct? Minimize this loss means the summation has to be minimum. So in addition to this, what else you can add? What else you can bring, right? Can I bring something else over here is my question. What do you fill here so that appropriate theta will be selected, right? Out of the three, maybe the theta 2 is the only one which is minimum. Other two are not to be selected. How do you say, how do you tell this equation that take only theta 2, not theta 1, not theta 3 is my question. Yeah, think about that. Not a very difficult concept, nothing very complicated, and it's actually very simple. Okay, very simple solution. So whatever answer you have given just now, lower values, minimum value, that itself is what I want to bring over there. Maybe you don't have to write the minimum because already there is a loss which is written arrow downward saying that minimize this loss. Okay, minimize this whole term. Whatever you write here should be minimized. That's all. Automatically it will be taken minimum, right? Because loss has to be minimized means the term which you write here, all the terms, sum of that should be minimum. So you don't have to worry about the minimization part, but just tell me how can you write a particular theta over there which is minimum. Automatically I should write only minimum. I should not write any other value. Such thing should come over. Is it possible? First question is that. If not possible, then there is no meaning in going further. If possible, then we have to think. Okay, I'll try to direct you towards the answer. All right, so there is a concept that is called as regularization. Okay, so the regularization is one of the most common what you call term associated with the supervised learning models, right? So what do you mean by regularization is, right, how do you keep a control over the parameters of your model, such as theta 1, theta 2, theta naught, etc. Okay, so regularization comes into picture by adding a penalty term to the loss function or the cost function. Okay, so normally this is adding a penalty to the cost or loss function. So it's remember the remembering this concept is very simple. So you see, I train, I teach my students, I train them again and again, maybe, and I do a testing. Okay, let's go for a testing at a later stage. Just look at the training part, and in the training part, I will perform the validation. During the validation, I'll come to know that whether a particular student has learned something or not. So far what we had discussed was, if he has not learned, he or she didn't learn, I should teach again. That's all. That is I am calculating a cost or a loss. If even after training 10 times, student could not understand, couldn't learn, means it's a bigger cost for them. So we were calculating a cost or loss function so far. But there are some teachers, you see, they will give punishment. Oh, I ask a question, you after teaching 10 times also you don't know, write it 100 times. What is that? That is the penalty. Okay, so you see, in addition, in the calculation of a cost or a loss, we will add a penalty to the machine, saying that, oh, you didn't learn after teaching 100 times, now you do this. Okay, so that is what is a penalty function. So this is how it's going to look like. My loss function L is equal to, let's keep the same thing. So this is I is equal to 1 to n. This is yi minus yi cap the whole square. This is a simple loss function. To that, let me add a lambda times summation, right, for all values. Okay, maybe there are maybe yi comes into picture, right? So let me write all the theta star. Okay, all the theta star I'll write. Again, I'll take only the magnitude, let's say. Okay, so because summation is being taken care, if I don't put a some magnitude, definitely some of the values will get cancelled. So if I try to do this, in the sense, you see the theta, what is my intention? My intention is to minimize this loss, correct? Loss minimizes when this is minimum and this is minimum. When this is minimum, under what condition your summation theta becomes minimum? Only when theta values are minimum. Right? So you see, automatically it's taken care of. Okay, so I just wanted you to think in this way. So this is one answer. All right. So this is the cost function. This is, yeah. Let me just check what I wrote earlier. Okay, right. So I had to write a lambda is a parameter. All right. So just to control how much of your theta value should come over. So this is a penalty term, and penalty term. And if you use magnitude of theta over there, right? So simply I wrote a magnitude of this. It is called as it's called as, what's the name? Lasso. Okay, this is, just remember this term. Okay, this is lasso regression. Yeah, it's a regression again. So it's called as a lasso regression, or this is L2. Okay, L1, my mistake. Okay, this is called as L1 regularization. So you put a penalty to the machine for not learning properly, and that is controlled by the theta values itself. Okay, so this lambda is a parameter which actually controls how much of your weight should be affected. In a sense, sometimes you may, normally the value will range between 0 to 1. So 0 means no penalty at all. 1 means complete penalty. Okay, heavy penalty. But 0.5, 50%, right? Whatever you do mistakes by not learning the proper theta. Okay, so not learning that theta means 50% of that will be a penalty. You can decide. Okay, normally anything around 0.5, 0.8 is what we use standard as a standard value. But yes, in during the programming you can change that. So the summation, you understand, summation of theta star means theta 1 plus theta 2 plus theta 3 or theta naught, whatever it is. That's magnitude means remove the negative terms, because some of the thetas can be negative also. Theta 1 could be 1.5, theta 2 could be minus 1.5. If I don't put a summation, that makes it 0. So I don't want that to happen. Okay, so there is a magnitude coming into picture. So star means optimum. Whatever it has learned so far, use it that itself as a penalty. So the whole term what you see here, L, right, that needs to be minimized. So this is called as L1 regularization, and the penalty that you add here is a lasso. That's a technical name given to that. So I simply take a magnitude of the theta value. In addition to that, you may also face another L equation. So summation, I just write this is yi minus yi cap. It can be anything. It can be magnitude or something. Let's stick to the same one we used earlier. But the second term you see here, that will be lambda times, this is a lambda, same parameter, summation magnitude of theta the square. If at all the square is used, again this will be your penalty term. You can write this is called as a ridge. All right, so this is ridge regression. That's one term. Otherwise, most commonly this is called as L2. Regularization. So these terms, this term will be much larger compared to the last one. Okay, so because theta squared, every term will be squared and then added up. But anyway, this is also going to eliminate your your negative term. So magnitude is not required. Simply let me make it as a bracket. Okay, this is simply bracket. So magnitude is not required. So you see, right? What portion of that penalty you want to put it over your the machine, put over the machine decided by the land. Okay, so okay, so we could understand that how do you uh, uh, what else you can do so that you can keep the theta values minimum. All right, so theta values are higher means it actually leads to a problem that is called as the overfit. We'll be discussing about that once we finish the classification problem. Okay, so how to know which one we can use, I'll come to that. Okay, so I just introduce you to some new concept. Okay, just that is necessary for us right now. But once we go ahead and understand some difficulties associated with the classification problem, maybe to solve that we will use one of them. When to choose what, I'll answer at that point of time. Okay, so we got introduced to the penalty term, which actually leads to a concept called regularization, right? It is used to solve certain types of problems. Okay, so we'll be discussing that at a later stage. All right, now moving ahead. So this all arises because we were having multiple solutions, and out of the multiple solutions, multiple straight lines, which one to be selected as optimum, right? Minimizing the error was the fundamental criteria that we had used earlier, right? We now also will stick to the same thing, but to the same term we add a penalty term saying that machine has to select the optimum based on a condition that keep those theta values minimum, because already we understood that this is going to have a lot of advantages, correct? So we have understood that. So we'll move ahead. Now our problem is to perform what is called as a binary classification. So remembering the concepts of the regression, right? For a given values of x, there was a value of y which was supposed to be predicted. So we did that. We had a normal equation, right? Get the values of x, right? And implement the normal equation so that you can fit a straight line for your given data so that you can predict. That's what we had done. All right. Now, what is our what is the idea here? The idea here being, now I know only regression. I have no idea what is a classification and how does the classification happens. I don't know. But right now I can say that my y column has only two values, either 1 or 0. Okay, so that's the first thing. And the second thing is that in order to make what you call a prediction, machine used a particular line that actually the line generated some values. The values itself were our answer, expected answer, that is y. But now we are not trying to implement that. We are trying to implement for a given set of x values, right? x1, x2, x3, x4, so many columns. I am supposed to predict a y which is either 0 or 1 only. Okay, problem is clear, right? So let me try to write one point here. What do I mean by binary classification? All right, so here we can set the target to the probability of that particular label is obtained. So think about this. If I use a regression, I can generate any number, any real number. What if there is a chance that I can convert the any real number generated by the linear regression into a probability? Why I said probability? Because probability means only between 0 and 1, correct? I can automatically, right, convert the linear or any real number, any real number generated by a regression, because I'm sticking to only regression, because so far we know only regression. I cannot bring a new concept all of a sudden. That doesn't make sense. If we learn, if we build a newer technology from what we already know, that makes more sense, because what I know I'm applying. So this is my idea. I don't want to go to a tree, binary tree, or a larger concept, SVM, PCA. No, I don't want to jump over there. I want to go step by step. Okay. So I know how a linear regression works. I want to use this linear regression to do a classification. This is my idea. I want to generate a probability, right? Let's say I want to look at what is the chance, what is the probability that a given input belongs to class. Only two classifiers, because if I know that given image is cat, right, if I can calculate a probability that okay, this given image has 90% chance that this belongs to cat, definitely you will say that okay, this belongs to class 1 because class 1 is cat, class 0 is dog, right? So makes sense. So that's what is our idea now. We can set the target to probability that a particular label is obtained. Means that, all right. So I'm trying to uh, calculate a probability somehow. How we'll see later. So I want to calculate. I want to do that calculation. All right. So that means if at all I am able to do this, means that implies what? That implies the following. Okay, I'll write another point over here just to make things more clear. Okay, so to make the regression a binary task, I can generate any numbers uh, from the regression, but I want to make sure that that falls between 0 and 1. Maybe coming closer to 0 means that event not happening, or the image is not cat, means it is dog. So I can even use that. That's why coming closer means other class. Closer to 1 means it's the same class. Okay. So to make that regression into, to convert that into a binary task, what are the things we require? We require a predicted probability. That's why the probability statistics are very important. We were stressing that from the beginning because of this. Right now, I can also put another say another condition over here. Something like if the estimated probability is greater than 50%, what do you decide? Okay, that means maybe it's class 1, or okay, I'll not write plus 1, that may confuse. All right, maybe that is implies that class 1 or some positive class. Yes, type of answer. So class 1 or maybe positive. You can label it as class 1 or positive, yes, anything like that. Okay, otherwise, else class 0 or maybe negative or no. So it becomes very easy now, right? Only thing is, how do I convert, how do I use all the x1, x2, x3, dot, 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 up to so many things, right? Given for a linear regression, it calculates a y value. How do I convert that y into the probability is my question. That's all. If I have an answer to that, my problem is solved. Because see the logic is very straightforward, right? I convert the all the y predicted values into a probability, because it can, as of now, this y cap can be anything, correct? Depends on what is my actual data. So my actual data has a y value like 30,000, minus 50,000, and anything, right? So the y cap will be something very close to that. No way I can say that it is a probability. But now I need a function which converts any given number, because you know y cap can be, say, ideally speaking, y cap can be negative infinity to positive infinity. Any number can be positive. So such a range, I should be able to convert such a range into 0 to 1. Okay, do you know any such function which I can apply? Is my question. Can I do that? Is it possible? Normalization. Okay. So normalization means you divide by the maximum number. Correct? That's what you mean. Normalization. Correct? You are dividing by the highest number. Okay. So if I try to do that, negative numbers will still remain negative, correct? When I divide by the highest number, I don't want a negative number. My complete range should be only between 0 to 1. Okay, so that's my point. Binomial. What is a binomial? You mean what do you mean by binomial, Gaurav? Can you elaborate, please? If you're talking about a distribution, we need more parameters, not just an equation of binomial, right? Binomial equation, if you see, there are many more parameters to get a probability out of it. All right. Now look at one equation. I'll call that. So let's say we have x given. Okay, this actually performs our normal linear regression. I get a y cap. Now I will pass this through a function so that output is between 0 to 1. This is what I'm expecting. So that question mark is what we are trying to fill. Okay. So any y cap that comes will be limited between minimum 0, maximum. Okay. So this is what, because minimum 0 means it is, I want a probability. Okay? So probability means I cannot go negative or not more than 1. Only because of that reason we have this question in our mind. Okay, so there is a function. Let me define the function. If anybody can recognize what is the name, if you give, I'll be more happy. Okay, so this is sigma t is equal to 1 divided by, this is 1 plus exponential of minus t. Okay, there is a function like this. Let's look at the characteristics later. So let's say put t equal to minus infinity. Tell me what happens. What happens to the sigma t?
Sir, please scroll down. Please scroll down.
Yeah,
I'm
just a
taking a
second.
screenshot.
Just give me a second. Okay, can you
Sir,
see?
scroll down. Scroll down.
Still, okay.
और थोड़ा सर हाँ yes.
Okay.
Yes, thank you sir.
Sure. All right. So let us assume that there is a function sigma t denoted by which is equal to 1 by 1 plus e to the power minus t. Now let us say, ideally speaking, y cap can be minus infinity to plus infinity. So we'll check what happens when you put minus infinity over there. So this becomes 1 divided by 1 plus exp e to the power minus of minus infinity is plus infinity, right? 1 by 1 plus e to the infinity. So what is this answer? Can anybody tell me how much is this equal to? One. Okay, let's check that. This is 1 divided by 1 plus infinity. E to the power infinity is infinity. So 1 plus infinity is 1 by infinity. 1 by large number. It's not 1, right? So 1 by, if you want to check that, you can use a calculator. 1 by 10, 1 by 100, 1 by 1000, 1 by 10,000, 1 by 1 lakh, 1 by 10 lakh. You keep doing that. As the number in the denominator keeps on increasing, what happens to your answer? It's not going to be 1. Okay, it's a different answer. Can you try? Infinity is a very large number, we cannot enter in a calculator, but you can understand what happens when it tends to infinity. So 1 by 1 is 1, 1 by 10 is 0.1, 1 by 100 is 0.01. You see, it's not tending to 1, right? It's actually reducing. What happens when you put a very large number over there? It has to be, yes, that's a 0. So that means whenever my input is very small, that is negative and towards minus infinity, my lowest answer comes, that is equal to 0. Next, put t equal to infinity and check what happens. Calculate what is sigma t. That is equal to 1 divided by 1 plus exp minus infinity. E to the power minus infinity, in the sense e to the power small number. You keep on reducing the e to the power 1, e to the power 0, e to the power minus 1, e to the minus 2, minus 3, minus 4, and so on. Now you understand something is happening. So that value you write. Okay, right? Let's check that now. So that means this is equal to 1 divided by 1 plus e to the power minus infinity, means e to the power smallest number. So if you check, right, e to the power 1, it is e, okay, it is 2.7 something. What is e to the power 0? This is 1. What is e to the power minus 1? 1 by 2.7. You calculate something smaller, 0 point something. E to the power minus 2, it is much smaller, still lesser than e to the minus 1. So e to the minus 10, if you check, it becomes 0.000 something. Okay, so I understand that my answer e to the power touches 0 when e to the power minus infinity comes into picture. So this is 1 plus 0. So 1 by 1, answer is 1. Okay, why we did this? Because, oh sorry, just give me a second. Yeah, okay. So why we did this? Because I had a question in my mind. For a smallest number, negative numbers, it's a 0. For the largest number, this is equal to 1. This is what was my question, right? I wanted something, I wanted a function over here which actually restricts my output only between 0 and 1. Something which is 0 and between 0 and 1 means what? It's a probability, correct? So I'm able to get that. I hope that is clear. Okay, so yes, we could achieve what we want provided we use this particular function. Okay, now I'll define the function. So this is what is one of the very famous function, right? We will be using this regularly when we touch the neural network part and beyond that. Okay, but now itself it is being introduced, and this is called as logistic, or more famous name is sigmoid function. Now you understand why the name logistic comes into picture. It's not a linear one. We are not trying to fit a straight line. We are going to fit a straight line and convert that answer into something else by using logistic. So it's a regression, but not a linear. It's a logistic. This function is logistic. Okay. So this is the function. I'll write once again. Sigma t is equal to 1 divided by 1 plus exponential of minus t. Now, if you plot, because I didn't plot so far, I'll plot it now. Okay, so this is the t value. This is the sigma t. So when the t, the horizontal axis is minus infinity towards the leftmost side, right? That is minus infinity over here. What is the value? It is 0. Correct? Just now we have seen. So it actually, this is a 0 on the y-axis. This is a 1 on the y-axis. Somewhere at the center, I'll also mark 0.5 just to make sense what was our intention and what this function gives. All right. So the function actually, right, put t equal to 0. Let's see what happens, because I want you to make sure that also, right? Put t equal to 0. What happens to sigma 0? 1 divided by 1 plus e to the power 0. Okay, because exponential 0, exponential of minus 0 is that. So this is 1 by 1 plus 1, that is equal to 1 by 2, 0 0.5. So at t equal to 0, this is going to take a value, okay, and that value will be equal to, let me check a voice once. Sorry. Okay, can you hear now? Am I audible?
It's working, sir.
All right. Okay.
So we can hear you.
Sure, sure. Okay. So at t equal to 0, right, you can see the value becoming equal to 0.5. That's why I marked the 0.5. So this is the limit, maximum limit, which is equal to 1. And the horizontal x-axis itself is the lowest limit. So it actually starts like this and it will tend to be 1 at t equal to infinity. So that's the maximum possible. Similarly, on the other side, this is how it's going to look. Okay, so you can see the function, this function, sigmoid function or a logistic function, restricts any value that comes. Any value in the sense you put x t equal to 10, 20, 100, 1000, 10,000 or infinity. It is still restricted, right? Less than 1. Correct? Less than 1, more than 0. Same thing happens even on the negative side. Minus 1, minus 2, minus 10, minus 100, minus 20, minus infinity also. It's still more than 0. Correct? So this is what we wanted, right? So this was our fundamental idea, right, of having a function which can, right, restrict any input value comes as a y cap from a linear regression into a probability that is between 0 and 1. Okay, is it fine? Are you understanding? Any doubt? Okay, so we have a function with us. Now, how do you create a logistic regression model? Okay, so we'll move on to that. So we have developed concepts here and there. We have many concepts. Now let's bring all together to build a model. Okay, so that is right. Now our our idea is this. So we have to perform the estimation. estimate the probability of a class. All right, using the h theta. You understand what is this? Already we have used it. I'm keeping it same, but now I'm not calculating a p. I'm not calculating a y cap or y hat. What I'm trying to calculate, I'm trying to calculate a p cap, which is a probability. All right. So this is equal to the sigma of x transpose into theta, because x transpose into theta is what? It is y cap. For a y cap, you apply a sigma. Okay, so this is done for each instance, each row of your table. You will do this. Okay, now what we can do here, just to understand this in more detail, simply try to compare the normal regression where the output itself is a predicted value. Okay, now in such case there is no modification, there is no sigma function coming into picture, right? I have a input given, there is a regression happening, you get a y cap. Y cap itself is a predicted value, no sigma function, no sigmoid function. Okay, but compared to that, I have an additional step here. Since the function used here is a sigma function, sigmoid function, logistic function, this is a logistic regression, but my output is right between 0 and 1. Now what I do, after I estimate this probability, okay, I can write predict a class, right? As now you see, this is my y cap is equal to, this is class 1 if p cap is greater than or equal to 0.50 else. Anyway, the else does not contain a huge set of values. It contains only values less than 0.5, right? More than 0 or equal to 0. 0 to 0.5. 0.5 is excluded. 0.5 we added to the other class, right? It depends. It depends on you. You can even bring the 0.5 to the class 0, right? Okay, that's fine for us. Right, it's left to us. We can make small modifications as per the requirement. Okay, so I can also try to write it in this way, right? 0.5 means I can actually write this. Whenever it is more than 0.5, this means the t value should be more than 0, right? My horizontal axis more than 0 means it is class 1. Less than 0 means it is class 0. Correct? So just let's go back to the graph to understand this once again. So any value that falls on this side is class 1. Correct? Any value falls on this side is class 0. I don't actually have to convert this into the sigma now, correct? Because sigma was just converting something between 0 to 1, but just to decide a class, I don't want that, right? Now I understand. If the t value is positive, it is class 1. If the t value is negative, including 0, it's class 0. Correct? Can I make that statement? Straightforward, right? So how do you get this t value? T value comes as an output of your linear regression. What is that output of linear regression? That is x transpose theta. Okay, so I can also write, this means if x transpose theta greater than or equal to 0, this means it is class 1. Easier version. Okay, so if x transpose theta is less than 0, means that will be class 0. I can even define using this. Okay, let me know if you have any doubt. All right, let's go for a training then. So model is pretty straightforward. I will ultimately on the base side, I will do the linear regression, apply a sigma function and make a decision 0 or 1, right? The class 0 or 1 depending upon the probability I get. Even without doing a probability, I can do. Now, let us bring the loss function into picture, because loss is very important. When to stop training, right? We need an answer, correct? So let's bring the loss function into picture. Okay, the loss function is one of the loss function we already have seen, right? You can take a summation of y minus yi. There are other functions as well. Okay, so I'll define another function now. Maybe you are seeing this for the first time, but you will see this, you will utilize, you will use this many times now on. Okay, so let me try to define that, right? So it's a cost function, so I got c of theta, right? Or c of the probability can also be written, doesn't matter. Theta is a parameter, that's all. Okay, it's my equation need not contain any theta, that's also fine. So this is minus log p cap. Okay, if the required value is equal to 1, target value is 1 means you apply this as your cost function. Okay, if the target value is 0, if it is class 0, then this will be minus log 1 minus p cap. Okay, this is if y is equal to 0. So this is another cost function. This is widely applicable whenever we have binary classification. Only two classes exist. Means this is one of the most powerful cost function, loss function. Okay, why? Because let's see this. I'll try to write it very quickly. So my equation has two parts. Okay, let me just show you this properly. Okay, you can see when y is equal to 1, if the machine predicts 0, that means there is an error. Correct? I repeat, look at the first line, y is equal to 1. What do you mean by y is equal to 1? My expected answer is 1. That's the right answer. But when the machine predicts that to be 0, okay, then the error should be very large. In the sense, the cost is very large. Correct? So that's what is the meaning of this. Let me try to plot both of them. So this is the loss graph corresponding to the first one, that is y equal to 1 case. And let me draw one more, and this is corresponding to y equal to 0. Okay, now this is c of theta, this is, let me write y here, this is again c of theta, this is for y. Okay, now you see, let's say y is equal to 1 here, the expected value 1, expected value 0. Okay, so when y equal to 1, I am supposed to use the first equation. Okay, so the first equation, if you plot and see for different values of p cap, you will understand that whenever it is 0, right, this value comes to be a very high value. But when y is equal to 1, see, y equal to 1 and your answer is also 1. Correct? Means no error. Right? So this is how the plot is going to look like. Okay, so at 1 you see no error because that is 0. When this tends to 0, when the y is, the calculated value is 0, you see very high error. That's what is expected, correct? So that's one. Same thing goes the other way, right? This is y equal to 1, this is 0. At 0 you don't have any error. That I'm supposed to use the second equation, okay? Because y equal to 0. When y equal to 0, if you put the p cap as 0, 1 minus 1, 0. So, right, sorry, 1 minus 0 is 1. Log 0 is equal, sorry, log 1 equal to 0. That's why it starts with 0. And as it becomes 1, it will be like this. So, you see, as the p cap tends to 1, the predicted value tends to 1, you have a very high error because expected is 0. All right, so this is the another version of the cost function, which is defined in two different parts. That's all. Okay, so though there are two parts, we can still use it because when y equal to 1, only first part, when y equal to 0, only the second part. Other part does not come into picture. Okay, so this is a loss function. All right, so in general, right, we will be writing the cost function for the complete training like this. Okay, so this is the loss function we have defined. I can write the cost function over full training data. Okay, thinking that I will give the complete data set at once. What you do, you take the average, correct? Because there are so many times the error is being calculated. So what you do, you take a sum of all the errors, all the costs you have so far, divide that by the number of samples, correct? So I can try to write it in this way. That is f of theta, that is equal to, it's 1 by m. There is a summation that actually takes 1 to m. All right, so I can write j is equal to 1 to m. J is 1 for the first row, second row, third row, like that. The last row is m. Okay, so we can try to write it in this way. Let me try to write the yj into log of pj cap predicted value plus 1 minus yj into log of 1 minus pj cap. Okay, so far we discussed only log and log of 1 minus pj. We understood what is that. So in addition to that, we'll write 1 or 0 over there, because this is going to come into picture when y equal to 1, right? So this yj becomes 1 at that time. To control which part should be considered, we multiply by yj. That's all. Okay, let me know if you have any doubt with this function. This particular equation, because earlier for every loss function we had given a name, sum of the squared error, root of mean square error, right? Mean square error.
Excuse me, sir.
Right? We have.
Excuse me, sir.
Yes, Ruchi, please go.
Sir, why we have taken this second term as 1 minus yj?
Okay, when you put yj as a 0, what happens to the first term? That is cancelled because yj is 0. But 1 minus yj becomes 1, right? Because I have to consider the log of 1 minus pj for that term. So to control which term should be considered, we use a yj because yj can be 1 or 0. Okay. When yj is 1, only the first term comes into picture. 1 into log of pj. When yj is 1, second term cancels because 1 minus 1, that is 0. So no second term.
Okay. Thank you.
Yes. So far we have, though we have used many of the functions, we gave a name initially, but since we didn't know that there is a log coming into picture and we use this kind of representation, f of theta, what you see here, we never gave a name earlier, because if at all I define something initially, maybe there will be some confusion. Okay, so the name for this particular function, which we are going to use, right, for many times now onwards, is called as a log loss function. Okay, you can get more details of this, you have to refer internet, okay, or any of the standard libraries which support the implementation of this, right, like scikit-learn or any other function, any other library will give you a broader picture of what this is. Okay, I want you to go there and do some research by yourselves. Okay, so that is the modeling part. How do you train and what you train, right? How to control the iterations, on what parameter you can try to stop the iteration, etc. We have seen now. Okay, that's the loss function. This has to be minimized ultimately. Is it okay? Right. Now, okay, let's try to look at the various schemes that are supported by these machine learning algorithms. And we know that we have to calculate the partial derivative, just to decide what is in which direction you move, correct? So for that reason, let's define what is called as the gradient. Right? I know that there is a cost function. I have to use the cost function to calculate the gradient, correct? So normally the gradient is denoted by delta I of f of theta. F of theta is your cost. So rate of change of cost is what is a gradient. We use the same thing even in our previous discussions. Okay, so maybe the notation is different, but just remember there was a gradient present, which because there we used, right, gradient of a different parameter. Now we are using the gradient of another parameter. That's why f theta comes into picture. But the concept still remains same. You are at the top of a hill. You want to move to the bottom of the hill. You have to take a step-by-step procedure. You have to see that where you have more steep position possible. If you take a step over there, you can come down quickly. Okay, so that's the overall big picture. Right? Try to recall our theory concept we discussed in the linear regression. Okay, so we are trying to implement that. So that will be, again, I'll directly write an equation here. We will not go to the derivation part or something like that. It's pretty much straightforward. There are m such iterations possible. So it is 1 by m, and I take a sum, so I divide by m to take average. So this is j is equal to 1 to m. You have a y cap, right? So I just have to perform that. So this is a y cap predicted minus y. So I can give a j here, yj cap minus yj, right, into your x, right, from jth step to the ith step, maybe something like that. Don't worry if you are feeling that j comma I little bit difficult to understand, doesn't matter. Like whatever is your input, you can say that. For a current input, I made a mistake, so I have to learn. How much you learn, you will start from your current value of theta. You have to come down, you have to come to a lower value of theta. So how much you come down will be decided by this equation. For the time being, just understand that. We'll be elaborating this when we go for some other topics. Okay, so this is the gradient. Now, what is the use of this gradient? Gradients are used for optimization, correct? So if you are not able to recall right now the optimization concept, after the session, I want you to go back to the material you got for linear regression. Over there, you will see one complete topic called optimization. There was a curve, something like this. You start from here, you come to here, right? So like this, you need to come, what happens, etc. was explained over. I want you to refer that. Okay, so that is the optimization which we are talking about. Now the optimization varies from your scheme. All right, for example, right, I'll just write this. So if you do normally, this is what we have seen. First order gradient means we will be using it as the batch or stochastic gradient descent, or even the mini batch. So many other orders also there. Second order, we have what is called as BFGS, many other what you call optimization techniques to exist. But as of now, let's not touch. So this is the equation. The first order differentiation, if you perform, we can use that itself for our batch processing, stochastic gradient descent. One by one, we give the data, or mini batch. Convert the, if you have 100 data sets, 10, 10, 10, you try to do. That's mini batch. All right. So these are the various points that are required for us to know how do you train. What happens with the train, right, is what we are supposed to consider. And the equation is pretty much straightforward, right? How this gradient can be used for the updation of the theta will be seen, right? So we'll be updating with that. So let me try to write one small part here. So what happens in scikit-learn? So scikit-learn, if we'll be using the scikit-learn, we'll implement two ways: one from scratch, one using the built-in library. Okay, that's scikit-learn. So normally, first the idea is what? If you remember, we need to import. Okay, so normally this will be the part of the code from sklearn dot linear model. We need to import the logistic regression. Okay, regression, logistic regression. Then you have to create a instance of your whole class. So how do you do that? Log reg. This is the name I give. I can give my name, ABC, anything. Okay, log reg equal to, okay, let's create that. That is equal to logistic regression. You can simply open and close. You can even specify what type of right what you call penalty you want to give. Okay, penalty equal to, if you want to give L2, simply write L2 here. Okay, then log right dot fit your X data and Y data. Okay, then log rig dot predict, right? Your X test is what you give. It gives a predicted value, and we can compare them and get the classification results. So over here in this particular method, in this particular method refers to the classification. Normally, we have many performance measuring possible. Okay, the performance measuring can be done using various metrics. So we'll be looking at that before we go to the actual implementation. Okay, but so the since the theory concept is completed, we'll do a simple coding part now. Okay. So far we were discussing about the theoretical aspects of a classification algorithm based on the regression. We call it as a logistic regression. Okay, do we have any doubts on that? Whatever we discussed so far, if you have any doubt, please let me know. Okay, I am sharing one file through our chat. Okay, please collect that and download it and put it into the same folder where you are going to run your code. And I'm changing the screen. So today we will introduce another programming platform that is called as a Colab. Okay, it's a Google supported platform. The idea behind this is everybody cannot access the high-end GPUs. So Google has built a cloud platform, and on their cloud we can write the code, we can run the code on their system. The advantage is that they have a good support for, in terms of the system storage, the GPUs and the RAM. So again, it's left to you whether you want to run on a Colab or on your system. Most of us prefer doing it on our system only. That's acceptable. But there is an option like this. Means I want you to get introduced to this. Okay, so that you can see the plus and minus of both our own system and the Google Colab site. And you can definitely decide, okay, which one to be used, which one is preferred, etc. Definitely you can decide. Okay, so what you have to do, you have to go to your browser and search Google Colab. Okay, so just search if you have no idea how to get this platform also runs on our browser itself. Okay, I don't need any other software to be installed. Not even a Python is required to be installed on your system. That's a something like a plus of Colab. Okay, only thing is that it requires a good amount of or a fast internet. If you say that my internet is slow, write I don't have a faster internet, then this may not be a good uh, what you call option to you, because you are not running anything on your computer. Okay, and you are running everything on the Google side, in the sense every code you type has to go to the Google's computer and it has to run. So for sending your code and receiving the result, you need a good internet. Okay, that's why I said internet is necessary. You open your browser and type Google Colab, a page opens, right? Click on that, the first link, Google Colab, and select a new file, create a new file. Something blank will come up. You can give a name on the top, as I change the name. Normally it will be untitled. Change it, and we are good to go. You don't have to install any libraries. Everything is pre-installed on a Google site. Okay, default libraries are already over there in the Google site. Okay, default libraries. Sometimes we may have to install. I'll tell you how to install. Normal pip install can work everywhere. All right. Okay, so that's what is needed. I'll give 2 minutes for everyone to do this. Meanwhile, somebody has to share the file in WhatsApp, please. Okay, because a few of you might not have received the file which I have shared. Kindly share it in your WhatsApp group, so that everybody can have an access of that. Okay, let me know once it is shared so that I can confirm that it has been shared. Please put a message when any one of you shares that particular file on WhatsApp. Okay, so Ruchi had shared that particular file on WhatsApp. Please everyone check. Thank you, Ruchi, for sharing it. Now, I hope everybody has opened the Google Colab file, right? And now I need to load my file to their side, because right now you have it on your computer, correct? It has to be loaded to the location where you are running this particular file. That means it's on the Google's server. So you have to upload your file also to that location. So you can see a files menu on the left side here. So simply click on that. Okay, so we need to connect, right? So as you can see, as soon as we click that, there is a connecting button that actually gets initialized, and you see a certain amount of RAM and the hard disk gets allocated to my computer. So if I can check, let me check. Yeah, you can see here, this has so much of RAM, so much of disk available. Again, Google has a business mind behind this, so they don't want to give everything for free. Okay, so they're not giving everything for free. There is a limit of usage for free users like us, right? So you have a maximum cap on the RAM that is available to you. So as and when the RAM requires, it keeps on increasing the RAM, but there is a limit. Okay, exact limit I'm not aware. I have not used the Colab for that extent. And also the maximum amount of memory that is allocated to you is also limited. Okay, you cannot get any amount of RAM that you require for your program. Any amount of hard disk that you may require for your data is also not available for free. Okay, but there is an advantage on this. You can go to the runtime and you can go to the change runtime time. Okay, wherein you have an option to change this to GPU. Click on this particular button. You will see that a pop-up window comes and it says GPU, TPU, etc. So if you really require a graphical processing unit or tensor processing unit, you can select that. But for our program, it is of no use, so I don't select that. Okay, but yes, freely it is available up to I think 8 to 10 GB of graphical GPU unit is available for free. Okay, only when required you are supposed to use it. Otherwise, it will identify that you are not using the allocated GPU. It will automatically turn back to the normal CPU. Okay, so it's not suggested unless and until really you require, you opt. Fine, so that's one thing, that's the advantage. And in a free version of the Colab, we can run a program maximum up to 24 hours. So for our application, it may look like 24 hours. Who is going to run a code for 24 hours? It may look like that, but you look at the practical scenario when we are going to discuss deep learning. Our program itself will run for 3 hours. In such case, the practical codes will definitely run for 2 days, 3 days, 5 days, or 1 week or something. Okay, so they are going to put a restriction on that. Practical apps you may not be able to build, right, by using the free version. You have to go for a paid version, which is called as Colab Pro. Those who require can definitely opt for. Okay, in the middle it will definitely suggest that, right, you can go for a pro version of this, and you can, right, those who want, they can definitely. Okay, that's the introduction part to the Colab system. And now I need to update this data. So you go to this particular button, what you see, upload to a session storage. Click on that. It actually opens up another window, and from there you select wherever you have downloaded this particular file, right? You can go to that location and you can simply select that. Okay, so I'll select from my system wherever I have stored it. Okay, I'll go to that location and I'll select this file. Okay, called the same, the social testing. It actually tells you one, it's like a warning, right? Whatever you upload is only for this session. If you close this session, reopen, that will not be there, because it's something like a virtual memory, right? You are getting a different memory location when you connect next time. So this, whatever you have stored over there, will never be present, right, when you run this for the next time. So in the middle, if you disconnect your system, there is an option called disconnect and delete the runtime. If you do that and you reopen the same file which is stored, right, like this code what I'm writing, it will never show this particular file exists over there. You need to upload once again. Okay, so for small files it's not a big problem, but if your program, if that particular file is like GBs or something, it will take time depending upon our speed of internet. So those are the positives and negatives of this whole Colab system. Okay, so it's there now. I can close this and I can start writing the code as usual. All right, so as you can see, it suggests something. If it's there directly, you can, right, you can click on that, right? Okay, once you uh, have imported all of them, you can run in a very normal fashion. Like shift enter will run a complete cell. Okay, so shift enter, See, it runs on the leftmost side. You can see it's running, and when it is successfully it ran without any error, it actually becomes green. On the left side, you can see a tick. All right. Next, I'll go to the reading of that particular data set. Read CSV. Let me look at the name properly and type it. Okay, so it's a social network ads dot CSV. Okay, so it ran. Now you can look at the data frame, right? What it contains, we always have to have an idea what is there in it. Okay, so df dot head. Okay, yeah. So this data set is something like the ads that we see on the social network.
So could you scroll up because I'm not.
Yeah, sure. Yes. Okay.
Just a minute, sir.
No problem. Take your time. Now, you see this data set, as we can see here, social network ads. As the name suggests, this is some ad given on some social network. And depending upon the ad, whether somebody purchased that particular item or not is there on the purchased column. Okay, the last column, what you see is a 0. And if you open that CSV file and please check that, I'm sure that there will be some ones also. Okay, some of the entries will be ones, some other entries will be 0. Okay, so I want you to check that. Okay, otherwise you can write a code, right? You can check that, right? Df of purchase dot unique, etc. You can use it to find out that as well. Okay, anyway, I'm not going to do the data munging part. That's actually a work for you to do now. So I want you to check the number of classes present, right? So in a sense, purchased values, how many unique values do exist? I want you to give me a command, right? So you type from your side, check it and give me that command. You type it in the chat so that we'll do that altogether. I'll copy and paste it over here, so and we'll check whether that is going to work or not. Okay, so how to check the number of different entries, unique entries in the column, in the purchase column, is what I want to check. Okay, just to make sure that that's my classes. Okay, that's my label. Discrete label should be present. I should not have continuous range. That's my first point. Okay, so yeah, we have an answer from Ruchi. Let's check that. So df of purchase, that particular column, tell me the unique values over there. So it says 0 and 1. So it should be very clear by now that it is a binary classification. 0 is one class, 1 is the other class. So what are your x coordinates? What are your x values? Right? That is, one is age, second one is estimated salary. So our idea or the whole problem is now, look at, given the age and the salary of a particular person, right? Now the machine has to tell whether he could purchase that particular item after looking at an ad or not. Okay, I hope the problem is pretty clear. All right. The next question is that find out whether there are any not a numbers, null, etc. present in the data set. If it is there, we need to deal with that. So how do you find out? Please go ahead, type your command, check it. Once you get an answer, put the answer in the chat box. Okay, I repeat my question. I want you to check how many. Yeah, so one more time, what is the problem here? Yeah, the next question I'm asking is whether there are any not a numbers. Okay, NaN, or do you have any none present in your data set? I want you to check, because that means there is redundancy in my data. I want to eliminate not a numbers, etc. Okay, so I want you to check that whether you have any not a numbers over there. So refer our previous notebook, right, which we had written a code, right? There you have a complete answers to this. We are most of the time we are repeating, okay, the same procedures. Yes. So df dot is null. Okay. First answer says is null, right? Okay, let's check. It says all the values, but I want an aggregation to be done. So I'll go with the second answer to check is NA. Null and NA will work pretty much same way. Okay. So is NA, then you dot give me a sum of them. All right. So this actually performs an aggregation. It adds up every column, how many not a numbers are. So if you get a value here, age 10, that means there are 10 not a numbers in that particular column. Now you see 0, 0, 0, all the three columns you don't have any numbers. Okay, yes, that's correct. All right, now, okay, I want you to separate, I want you to put x equal to, in x, I want, say, age and estimated salary in the x variable. All right, I repeat, in this x variable, I want you to copy the complete age column and the estimated salary column. I want them to be coming here. Okay. Okay, x equal to age and estimated salary. You have to be specific in terms of x off, correct? From where you are supposed to take, because if you simply type this, okay, let's check. Maybe the newer versions are different. Let me check before I give a comment. Okay, it says x equal to estimated age and this. All right, so let's run this and let me check. It says if you try to check your x now, let's see what happens. It's only this much. You see, I'm not having the complete all the rows under that particular column. It's not coming over here. Okay, so we go to the next answer. That is, yeah, Gaurav says put data before this. All right, so I have given df. All right, I think I typed different. You said plus, my mistake. Let me check that. Okay, so data of, sorry, that's my mistake. Age plus estimated salary. I think that's a error. Okay, can you check? I want complete all the rows to be coming over there. If you know the column numbers, you can use iloc, index location. For example, I'm trying to give a hint. Okay. or maybe df of, again you can write one more df. Okay, yeah, maybe one of the column you can directly extract, but two columns it may not be possible. All right, so df of, now you write something here, just check whether that is going to work. Okay, df of, maybe you see age, it already suggests age. Okay, and I can also write, maybe just check whether you can enter the, okay, location is another method. If you know the exact names which you want to put, you can use LOC, location. If you don't know the names of the columns you want to index, then ilog will work. Okay, I hope that that's going to work. Let's try to put that. Right, I'll try to copy and paste it over here. All the rows and those columns. Okay, so it says it's able to run now. Let's check. I checked the capital H. So yeah, 400 rows, 2 columns. Yes, one of the answer. This works. Others, please try. There are multiple ways in which you can do. Okay, so this is one of the possible answer, and yes, this is the correct answer. Okay, now I want you to put. Okay, let me type the X here itself, and I want you to put something to Y. What should be the Y now? Since there is not a number, there is no processing happening. Everything is in the required format itself. Okay, I don't have to do any of the data processing. Pre-processing is not required. No munging, nothing. Directly we go to the. We'll define. This is my training data. This is my input. These are my X values, and this is my label. Where is label? Label is present in the, I think, purchased column. Can you put it over there? I want you to put the last column, that is purchased column, to Y. Okay, you have one answer coming. I'll just check whether that works. Yes. Okay, so now what do you suggest? What will be our next step? So somebody had asked me a question in the previous session, that what will be the standard procedure in which we go ahead, irrespective of whichever algorithm we are going to apply. Right? So I told this that answer earlier, saying that this is what you do. You make your data set ready. Once the data set is ready, what you are going to do next? Look at that. Look at that answer where we did the linear regression part. After the data set is completely ready, what you did next, we are going to do here. It's because it's the same. Okay, can anybody check that and answer? Yeah, we have to build a model, but to build a model, something to be done with the data, right? I cannot give the complete data to the machine to build a model, correct? Build a model is correct, but that's the third step. What is the second step? First step is data, making ready of a data set. I have a data set ready. All column as int. No, not necessary. Dividing the data. Okay, you split your data set into training and the testing data. Correct? Do you remember that? Let's do that. So already we have imported the required function. If you see, right, you can see here. This is the reason why we have a train test split function imported from the sklearn model selection. Okay, right? Okay, let's do that. It actually provides you the answer in the following format: x train. The test data will be given after that. then the labels y train, any name you can give here. A, B, C, D is also going to work. Okay, just to understand what we are, how we get the answer, I'm giving the appropriate name. That's all. Simply give A, B, C, D, it will work. Okay, y train, y test should be equal to, call the function. That's a train test split. You have to tell what's your data points, what are the labels that you have, and you can even specify train size or the test size. So as soon as you enter, it actually tells you, right, what are the various things that you can give here. Either you can give a train size or even the test size. Okay, so test size equal to, normally we write a fraction. I'll give say 0.25. Let's see. And again, you have many other options. You can give a shuffle, stratify, many things are there. Let's not use it any of them as of now. I'll use it when required, when really required. Okay. So we'll split that. Okay, now we can check the number of elements in the training data and the testing data. How do you check that? What is the size of the training data? Can anybody give a command to check that?
So what's the question?
I want to look at the size. How many elements are there in my training data? X train, right? Yeah, I think we have an answer. How many elements are there? How many rows are there in that? So one of the answer I think we have here. Let me check that. If you have any other answer, any other command to check the same thing, please put it in the chat. Okay, so it says X train dot shape 300 rows, 2 columns. Okay, it's an expected answer because we totally had 400 in our X and Y, 400 rows, as you can see over here, right? It says 400 rows. So out of 400, if I take 25% away, 300 remains. That will be my training data. Okay, so you can even check with the shape 100. Same thing will go with the Y train as well as the Y test. Okay, 300 comma 1, 100 comma 1. Okay, now try to recall what was the intermediate step we had, just to make sure that all our columns will affect the same way or with the same proportion. They will contribute in making a decision of Y. What is it called? There was a step, there is something, there is a specific step to be taken just to make sure that every column contributes with the same proportion, okay, in making a decision of Y. What is it called? Scaling. Okay, so it's actually there is what is called as a standard scaler. That's what we had used it, if you remember. So we can use it. It's again optional, right? You can, I want you to write your own code without using standard scaler, okay, and afterwards using standard scaler to verify. Okay, so now I use it, but I want you to explore what happens if I don't use as well. So okay, so let's bring the standard scaler, let's import it. So sklearn dot it's present in the pre-processing. Yeah, sklearn dot pre-processing, you import, yeah, standard scaler, import that. Okay, then you create an instance of that. You can call it by any name. So SC is equal to,
Sir, can you please tell what's the standard scalar again?
standard scalar is it's actually a scaling operation which tries to normalize your complete column.
Okay, to normalize it.
Yes, such a way that
Okay.
it affects equally. Every column has an equal proportion of weightage in deciding the value. Okay, so last time we have used it, if you remember. Okay, so we create this, and now what I do, extreme is equal to, you will fit, okay, SC dot fit transform. You can give the same name here, extreme. Okay, now I want to do the same thing with X test. So remember one thing. This is new to us, so I'm trying to explain what is happening here. So there is a SC which actually standard scale, which is a standard scalar, which actually tries to fit that particular operation, standard scalar operation, and transform your X train into a particular size, particular data set. Now, once you use it, in order to use the same thing again for a different data, okay, because we have split X train into X train separately, X test separately. Previously, we didn't do that. I had a reason behind it. I wanted to show you in this case how to do it separately. Either you take the X completely before you split. Before you do the train test split, you can apply the transform in a single shot, like how we did in the previous session. Okay, remember, that's how you do it. That's if you have the complete X readily available before you split the train and test. But now you see there is a separation already happened. X train is separate, X test is separate. Now also you can apply the standard scalar, but the technique is slightly different, not difficult, slightly different for the second application, that is X test. You don't have to fit once again, because fit in the sense apply standard scalar. Fit means you are trying to fit that. Transform means it is converting. So fit and transform, there are two operations happening over there, but you don't have to do the fit once again, because fit means this data X minus mu by sigma is my equation. I'm just saying that that's my fit. Transform means this is my data, convert that into a different data. That's what happens with the transform. But now the fitting is actually happened. It's done already. You don't have to fit once again. Simply you do this. X test is equal to SC dot transform. Okay. On your same data, that is X. So once if the fit transform already happened once, you don't have to do the fit transform again. Simply do the transform is the meaning. All right. So let me know if you have any doubt. I'll run this one. Now, if you see, so I think we have a train X test already. If you have seen the X test already earlier, now the X test will be completely different. Okay. So let me try to write X train. See, the values are completely changed. Can you see? Because the first one was age, second column was the salary. But now you see, it's scaling happens. Standard scaling is refers to this.
Sir?
Yes, Gaurav, please go ahead.
Sir, in line number 19, please scroll up.
19, just a second. Yeah.
Yes. Second line, X train equal to XC dot fit transform X train. In this, it's showing me an error. Says that fit transform missing one required positional argument X.
Have you given the X train here inside the bracket?
Yes, sir. Yes.
Okay. SC dot
so
is
both of the X train are same, right?
Yeah, both are same. I'm having this X train, converting that into the same. I'm storing the answer in the same variable.
Okay.
Okay, you can save in a different variable if required, no problem.
Hold on a sec. Can you please just copy paste this line into the chat box?
This line, okay?
Yes, sir.
Sure, no problem.
Excuse me, sir.
Please go ahead, Ruchi.
Sir, after using fit one time, when I am not using fit for the other data, it is giving me error. But if I am using fit again, then it is giving me the correct answer.
Oh, that's something new to me. Okay,
Yes, sir.
check both of them. Explain you print, test also you print. If both look very
Yes.
similar, you can keep that. Okay, but normally this is what
Yes.
happens. Once you fit, you don't have to fit it again. It actually gives some little more burden for your computer. So it's not suggested, but if it's not working, then you don't have any other option. Maybe the version of sklearn install on that particular system where you run is slightly different version. Maybe that's the only.
Sir, I'm using Google Colab.
Colab only, right? Okay.
Yes, sir.
But
sir, again it's showing me the same error.
Sir, if I am using fit again for every train and test data, then it is giving me correct answer.
Correct answer. Okay, no problem. Stick
Yes,
to that.
sir.
Okay, but the actual concept is what I explained. All right, so you don't have to call it again. Just remember that. Okay, right.
Okay,
Gaurav, check which version of. No, have you? This is there, right?
I am using Google Colab.
Okay, you have this line, right? This line.
Yes.
Did you run this
it's
line?
It's working fine.
It's
yeah,
fine.
right.
So this line is also working fine, right?
Yes.
Okay. Now you do one thing. Remove these two lines from this cell and run this SC equal to standard scalar once again, and paste these two lines in your next line and check what happens. Okay.
Sure.
Maybe that
Let me
will
just
work. Let me check.
Okay.
So as a result of this scaling operation, you can see that the two columns which you had, right, they are now converted between the values between, right, around 0. It's a normalization. That's what has happened, right? So you should be able to see that. All right, let me remove that because it actually prints a lot of numbers on my screen. So I just don't want that. Okay, so let's go further. Once you do this particular, what you call as the standard scalar, right? What should be your next step? Can anybody suggest? I have dataset ready. Dataset has been split up into two parts. What do you expect? What should be the next step? We have the logistic regression. I think the model is already present with us. You can see here, yeah, logistic regression has been imported. So that means I don't have to wait. I can go with the training part, right? So just these are the lines I wrote in our notes in the very last part. Okay, so you have to fit your data now. Sorry, fit the model now. So previous fit was not logistic regression. It was standard scalar. I was right using the scaling operation on my data. That's all. Okay, but now I have to fit the logistic regression. That particular model needs to be fit. Okay, so we do that. So create a particular variable for that. I'll call it as a log reg equal to its logistic regression. Okay, do that. It's done. Now directly call logistic regression dot. Now you fit. Okay. You just have to tell what is your input and what is the expected output. So that is x train is my input and x not X test, sorry. X train and Y train, my mistake. X train is this. This is my data. This is the required label of the class. I just have to tell. Okay, so we'll do that. It may run for a few seconds. Okay.
Excuse me, sir.
Yes, Ruchi, please go ahead.
Sir, when we are using this log regression is equal to logistic regression, so do we need to add penalty here or not?
That's optional case, right? Right now I'm showing, right, the default one. It will take all default values. Whatever is the, you can check that like this. So logistic regression. So you can write a question mark and check that what actually assumes by default values, etc. You can see on the right side. It gives you a clear-cut explanation saying that if you don't enter anything, what are the parameters it's going to take. So you see, default is L2. When I don't mention it, will take L2 like that. So there are other parameters also that's present over there. Whenever you don't enter anything, it will take them. That's why I have not given anything. You have something specific in your mind, you can specify. Okay, you can write there those values. Okay. So writing those options are there definitely, right? Other than the default values, if at all I want to use something very specific, I can define that. I can define penalty. Okay, I can even define what are the do you want to perform gradient descent, do you want to go for a batch, etc. Everything is there, okay, in that help which I mentioned, right? You just have to see which format you have to give. You just have to copy and paste it over here. That will do that job.
Okay. Sir, I'm getting error. Why should be 1D array?
Y should be 1D array. Just check, just type your Y train and Y test. Okay, just print or look at the size of that. It should be a one-dimensional. If you have multi-dimensional, then that error comes up.
So both are having 2D. I mean the 2 columns.
Both Y train and Y test, correct?
Y train and X train, sir. Sir, we are using X train and Y train.
X train can have 2, no problem. Only Y train is a problem for you. Okay, so
Y train is getting 2, sir.
Y train
100 cross.
See, 300 cross 1. Just check your Y once again. Okay, because I typed Y here, it's actually giving 400 rows, 1 column. You check your Y completely. Once again, check Y.
The Y is 401 column.
Okay, then you see what has been entered over here. Once again, can you check? Because if something is different over here.
Oh, yes, sir. X, okay. Yes, sir. Yes, sir.
So that's the problem. All right. So Y has to be only 1 column. That's why it's an error. Okay. All right. Next step is, okay, now the model has been fit and the model is present in this name. Okay, log reg is a logistic regression. That is our model. Next is I want to predict. Okay, before that let me try to make a prediction, right? I'll give a number and let's try to make a prediction now. All right, so let's try to that is log reg dot predict. I have to give 2 numbers. What are the 2 numbers? One has to be age and second one has to be a salary, right? So let's try to look at that, but I cannot give that directly because while learning, machine has considered the standard scalar value. So I have to do that now. So I'll just do sc dot transform. I don't have to fit. That's why I do. I don't have to do a fit here. I'll do a transform. Okay, let's see what happens. Let me enter the two numbers over here. Say age, let us say 25, and I'll give say the salary 4, 5, maybe 60,000. Will it work? Yeah. It says it's class 0. Okay, I don't know on what basis, because we have no idea about what is the condition to decide whether he purchased or not. I don't know. I randomly entered some number. So his age is 25. Convert this, transform this according to our standard scalar. 60,000 is the second column value for that particular user. Now use this data and give me a prediction using this model we built. It says it is 0. In the sense he didn't purchase. Okay, let me change this. Let's make it 45. Let me say, let me reduce this. Let's see. I don't know whether it will work or not. Again 0. Maybe salary needs to be high. Possible. Let's make 85,000. Yeah, now it says. Okay. So you see, I'm checking my own instance. I'm giving a randomly generated data to check this. This is what is called as a sample test. I'm just doing I'm giving one sample and testing. This is not present even in our test data. I'm generating randomly and I'm testing it. Okay.
Sir,
yes, go ahead. Please go ahead.
Sir, in number 19, line 3.
Okay.
X test equal to sc dot transform x test. Okay, it's showing me an error saying that x has 1 features, but standard scalar is expecting 2 features as input.
Okay. In such case, you check your exit train and x test. I'm expecting, you see the line number 16 and 17 in my this thing. So you should be getting something like this: 300, 2, 100, 2. Because it's expecting 2 columns and yours has only 1 column, it says.
Check.
Okay, can you check that? It is expecting 2 columns. All right. So dimensionality
it is showing me 300, 1. X test.
X test is no. X test should be lesser size. X train should be 300. So just check what you have entered here. Can you check this line once again? Line number 15 in my testing. Okay.
Okay, sir. If it is 300, 1, then how do I do that? 300, 2.
Because you have to pass the X here. X is a 400, 2 data set. That's why it is taking converting the 400, 2 into 300 and 100. Correct? Only when you pass X as a 2 column data, it will convert that. I think you passed X as only 1 column. That's why you are facing that. Okay.
Okay. Let me check.
Just check that.
Sir, I am getting X train is 100 and X test is 300.
Just check what you have entered here. Test size or train size?
Train size.
That's why. Okay. You are getting train size lesser. I am getting test size lesser. Okay.
Okay, got it.
Change that to the train size to test size. So test size becomes that. If you want to use a train size, give it 0.75. In the sense, 75% should go to the train. Just either change the 0.25 to 0.75 in your case. It will rectify.
Okay.
Okay.
So every time X test should be smaller.
Yeah. Testing data is smaller. Training data is larger. Okay. It's something like when I train, right? When I teach, my teaching hours is very large compared to the test hour. Test will be just 2 or 3 hours. Okay, but the training happens for 1 full year. You see, that's the concept.
Okay, got it.
Sure. Okay, so we have done till here. Okay, so you can see that I generated a random sample and I gave it. Machine says, okay, this is your answer, right? So now let us see, let's look at the accuracy. How good was our system training? We can look at that. We have to go for a parameter called accuracy. All right, so let me try to write a small part of the code, which actually using which we can see the actual data and the classified data, right? So that we can have a clear idea about it. All right, so what I do, I'll create the variable y predicted. That means machine is going to predict this as the answer. So this is a model. I am asking the model to predict. All right, so log reg dot predict this model. You predict me the answers for what machine does not know. What is that? What is that machine does not know? We have kept it aside, right? The test data. I'm giving the test data now. That is X. In a sense, I'm going to ask the machine that, okay, this is the data now. These are the questions in the exam. Give me the answer. Give me your answer. So that answer my student writes is going to come in the y predicted, so that I can compare y predicted with the actual answer, that is y test. Y test is the correct answer. Y predicted is the answer that I'm going to get. So I can compare, right? So I'll get this. Okay. And next I will go for, I'll try to print out something. Okay. np dot concatenate. I'll concatenate two things now. Okay. The first thing is the y predicted. I'll try to do a reshape. What should be the shape? It's length. Oh, sorry, this length, my mistake. It's a length of the y predicted, comma 1. Okay, comma y test dot reshape length of y test comma 1. Okay, and concatenate, I have to tell which direction, so I'll write comma 1 here. This is the closure of our that. This is the closing of this. This is the closing of that. Okay, let's see. Some error. Y test is not defined. What was my variable? Sorry, I think I missed my variable. Y train is there. Where is Y test? Oh, that's my mistake. I have given capital Y test. That's the only reason. Okay, so Y test. That's a mistake. Let me check once again. I am trying to print np concatenate dot reshape length of y predicted comma 1, then comma y test dot reshape y test comma 1.
Sir, I think T is capital in test.
Which one? Y test. You are saying about this
Yes,
one,
sir.
Y test. Actually,
Yes.
I made a mistake here. You see, while entering, you see, my Y test
Okay,
is
okay.
written like
Yes,
this.
sir.
Okay, so
Yes,
that's
sir.
why
Yes.
I changed everything.
Mhm.
So actually, that's not a problem. It says the reshape function is not defined for data frame. That's the reason why I converted into the numpy. But still it's saying there is an error. Some brackets, let me check. Okay, some brackets are missing. So I start with the bracket over here and I open two more brackets. Bracket number 3, 4. This is 5. So I close a bracket. I close another bracket. Comma. Okay, let me try to. Still it's the same. np.concatenate. I want to write in the next line because those who are copying should be able to see that's the, okay. Let me check once again, one more time. Otherwise, I'll change the whole command. That's all. Okay. So y predicted dot reshape. I reshape this according to the length, one column, and next to that, I want to print the y test dot reshape. Okay. It's correct only. Okay, y test, length of y test. These two are closing. This is closing here, closing, comma 1, comma 1. Oh, this is right. Okay, let's do one thing. We'll do this later. Okay, I wanted to print both of them together so that actual answer is 0, predicted answer is 0, actual answer is 1, predicted answer is 1, like that. I can see some of the mistakes it has made so far. I just wanted to have a look at that, but anyway, right now it is not happening. I don't want to waste time. All right, let me go ahead. I'll come back to this later. Okay, or when I share this document to you, right, I will correct that and I'll put it over. Okay, so let's not waste time here. Let's go ahead. So next I want to look at, say, the what is called as the accuracy. How accurate is my system? I just want to see. Okay, so sklearn dot metrics. It contains the performance measurement, various measurements for the performance. Right, metrics are there. The various metrics are there. The first one is called as accuracy score. Okay, so I just have to call accuracy score of, I have to say what are the two variables that you want to compare. The first one is y test. This is the right answer. I want to calculate accuracy score by comparing the right answers with the answers that machine has given. Correct. So what are those two? One is y test. Another one is y predicted. 0.88. You can multiply by 100, 88%. So there is an accuracy. There is the accuracy of our machine. Our model is 88%. Okay, directly you can do that. Otherwise, what is the logic? What is the logic behind calculate accuracy? There are correct answers, right, divided by the total questions into 100, right? That's all. So I just have to do that. So you can apply a logic, write a function, write a program to do that. But anyway, the scikit-learn matrix already has a built-in function. You can simply call it and just have to tell, okay, compare the y predicted answer which machine has given with the y test. That's all. Okay. All right. That's one parameter which we normally use. And let me bring another performance measurement matrix now, but we may not be able to give a very clear-cut explanation of that in this session because it's something new. You might not have heard or might not have used it so far. So that part we'll take in the in tomorrow's session, and we'll be discussing in detail about that. Okay, but I'll bring it over here since we have say 5 minutes of time. Okay, so accuracy is very clear. Any doubt with the accuracy part? How to calculate? What does it mean? Everything is clear, right? It's a normal accuracy which we calculate. Okay, so number of correct answers, correctly predicted values out of the total divided by the total number of questions I have asked. That's the length of your Y test or Y predictor. Okay, so the second performance measurement metric is again present in the sklearn matrix. You import what is called as confusion matrix. It's there. Okay, bring it. Then, right, print confusion matrix of Y test, comma, Y predicted. So it says, it gives a matrix. So this matrix has the following parameters. One is called as a true positive. Okay, true positive means actually they belong to class 1 and they are classified as class 1. Okay. Okay, one more question from Gaurav. Let me answer that. Come back. So log predict sc dot transform 45 comma this giving you an error. Okay, let me show you my part of the code. What is the error? Standard scalar has no attribute. There is a spelling mistake. Can you check? Transform. S is missing. I think that's why. Okay. Sc dot transform, right? I think that will solve your problem. Okay. All right. So I was discussing about the confusion matrix. So the confusion matrix A has one of the parameter called a true positive. Okay. True positive, and another one called true negative. True negative in the sense it was negative, it was a class 0, and your machine actually classified that as class 0. Okay. So correct answers. How many correct answers your machine has given during the prediction, during the classification, right? You can try to identify that by using true positive and true negative. Right. So two parameters. I will discuss this in detail in the next session. That's tomorrow. But right now, since we have plotted, I just want to bring in the meaning of that. Okay. And okay, so there is another problem coming. Let me go back. So in the training part, you have an error, right? So this one, great dot fit. So if there is no error here, I don't expect any error coming here. What's the error that you get? Can you please check that? X train and Y train.
Sir, error is unknown label type continuous.
Label type is continuous. It says your Y is not a categorical like 0 and 1. It says it is a continuous variable.
Yes,
some issue with that. Can you try to print out like this Y what we have printed? Can you see that this Y is looking like 0, 1 only, not any other value? It says your
yes,
numbers.
Sir. Yes, sir. It is looking like 0011.
Only zeros and ones, right? Okay.
Yes, yes, sir.
Then okay, check your Y train and Y test once again.
Sir, Y train is 300 cross 1 and Y test is 100 cross 1.
Okay. Then let me check. running ones, log_rig dot fit, okay, x train comma y train. Can you read the error once again? Let me try to recall what's the mistake.
Sir, error is last line is value error, unknown label type, and in that is written as continuous.
That should not be a case.
Yes, sir.
Can you check what is the data type of your y? Okay, y data type. It has to be integer or categorical.
Okay. So it is integer.
It is
D
integer.
type is object. Sir. Purchased. Sir, it shows purchased is integer 64 and D type is object.
There is some text present in it somewhere there is a this thing, okay, because it cannot be object, right? Object means
Yes,
it is
sir.
something other than our numerical data, okay.
Yes, sir.
So that's why it is giving some error somewhere in the middle. Something changed, some of the values. You check the unique values. Let's check that. In y, can you check the unique values once?
Okay, sir.
Maybe you will be able to trace that out. Okay, so remove whatever comes new, try to remove that so that it becomes only this thing. Otherwise you run everything from the beginning, maybe that will resolve the issue. Somewhere in the middle you have it, some other data type present.
Okay, sir, I will check it.
Okay.
Yes, sir.
Okay.
Yes, sir.
Sure. So now there is a matrix here, 54, 1, 11 and 34. So the low on the horizontal axis, you can say that is a truth. On the left hand side, whatever rows you have, that is actually the predicted values. So truth, right? So this is say class 0. First column is class 0, second column is class 1. First row is class 0, second row is class 1. Let us assume. So out of class 0, how many are predicted as class 0? 54. Out of class 1, how many are predicted as class 1? That is 34. So those are the correct answers. Okay, now you see, first column is for class 0, but second row is class 1. Out of class 0, 11 are misclassified as class 1. Again, the second column is for class 1. Out of class 1, first row is class 0. How many are predicted as class 0? One of them has been predicted as class 0. So, how many correct answers, how many wrong answers are made class wise, I can see here. Okay. If you have 4 classes, your matrix will be 4 into 4. Okay. Right. So, that's the meaning of a confusion matrix. Where is confusion here? The main diagonal is not confusion. It is the correct answer. So, the 54 and 34 are correct. Confusion lies along the other diagonal. All the other elements than your main diagonal are called as the confusion values. So class 1 classified as class 0 means there was confusion. Class 1 classified as class 0 is also confused. Okay. So that in this particular matrix, it lies along the other diagonal of it. Okay. So anyway, I'll just stop this discussion because I have to explain a little bit more over here to make things very clear. We'll draw something, we'll draw the matrix and we'll analyze
So
that.
I'm getting different answer here. I'm getting 53,
No
4 and 33.
Absolutely fine, because your machine generates different random numbers, so slight different answers are expected. Okay, no issues, absolutely fine. Okay, so that's what is the meaning of what is called as a confusion matrix. How much confusion machine has during this whole classification, we will be able to note. Okay, in addition to that, we can also generate what is called as a classification report. We can also bring in the parameters such as precision, recall, and F1 score. Many parameters are there. Each one has its own significance. Then using some graphs, we can do the analysis. Okay, so there are many more things like this coming. So we'll do that in the first thing in tomorrow's session. Then we'll take up the actual problem. We'll define a bigger problem. We'll take a bigger data set and then we'll do the data analysis over there. Then we'll do the classification. Okay, logistic regression classification over there. So that's what is going to come next in tomorrow's session. All right. So I'll share you this my document, which actually has run completely, right? Just hold on for a second. I'll share in the link now itself. Okay. So I just copy the link. Now itself you download. Okay.
Okay, sir.
I'll put it in the chat box. Okay. You get a link now. So click on that. My whatever I have written here will come on your screen. You save it. Okay. Save as or download as, do something so that it comes to your computer and you can run more. Okay. You can run even in the you don't have to run only on the Colab. You can even download it and run it in your Jupyter notebook as well, because it gets saved in the same IPYNB format. Okay, so IPython can run this. All right, so do this, and tomorrow I'll be continuing the session in the same notebook, so that tomorrow at the end I'll share the link once again so that everybody can have access over. Okay, all right, any doubt?
Yes, okay, sir. Thank you, sir.
Sure. All right. So I hope this session is good for you, and I appreciate all your efforts in executing the program and being a part of this session. All right. So we'll meet tomorrow and we'll continue from here.